Okay, welcome to Defn, episode number 39 with Dmitri, all the way from Canada.
Hello.
And this is Vijay from Holland, and we have, as usual, Ray from Belgium.
Hello there.
So, welcome to the podcast, Dmitri. First of all, I think there are two questions from my side. One is, I think I want to start with the most important question to whether to continue this episode or not. Emacs or something else?
Yes. So I actually use IntelliJ with cursive.
Oh, yeah. Okay.
Yeah, that's it.
That's it. That's it. I'm out of Clojure world now. God damn it.
But a friend of mine actually at work does use Emacs. So he's been trying to convert me. We'll see if it happens. No promises, but I'm open.
That's pretty bad. That's a really bad way of saying, oh, I know a brown friend who has a brown friend.
Oh, wow.
I get to say that, by the way.
You know some nice white people, I guess.
Exactly.
I don't know if you do, actually. Yeah.
Believe me. Okay, so, and your internet persona, what is Yogtos?
So yeah, I knew this would come up. So it originates with, I was into Lovecraftian mythos for a while, and all the existential horror and so on. And of course, all his cosmic entities have this weird and unpronounceable names. And there's one that called Yogtos Iceland, and I kind of just mangled it. And then it turned out to be really handy for online handles because it's completely unique and nobody takes it. So every time I go to a new site, I have a handle ready. But then it also became a bit of a personal joke because in Lovecraftian mythos, it's often, the protagonist discovers some cosmic knowledge beyond human understanding and just drives them mad, and people look at them like, they become crazy and outcast from society. And it's kind of like how people view Lisp often, right? It's like it's this weird language with this weird parens, and once you learn it, that's it. You're lost to the world. So it's become a private joke for me.
It's a deep story. It's not just your cat running across the keyboard or something. I thought that's going to be a bit more mundane, but this seems to be super deep. Okay.
So did you discover Yogtos or Lisp first then?
I actually discovered the handle first, and then I just kind of worked it into...
Okay, it became the thing.
It became
the
thing, yes.
GNU is not Unix type thing. Yogtos.
Exactly. It's not existential horror.
So how did you get into Clojure? So walk us through the history of you getting into Clojure.
Yeah, sure. So, when I went to university, right, there was kind of like that standard program where it was mostly focused on being a Java factory. And I learned object-oriented programming and, a lot of Java. And basically, I thought that's the way you develop software, right? You make objects and patterns and classes, and, it all makes sense. And then I started working in the industry. And of course, when I was green and new, I didn't really know any better, right? And I would work on those Java projects, and I would have this feeling like, wow, this is so complicated. This is so hard, right? But, I'm new. Maybe I'm missing something. Maybe I don't understand, and there's going to be some purpose to it at some point. And I worked for a few years.
What did you find complicated about it, Dmitri? Because it's interesting to me what you found. What did you find that was complicated?
Well, specifically with Java, it's the use of patterns, right? Like stuff like dependency injection, AOP, the way app servers work. And then these patterns they're supposed to make things very generic, right, and reusable. But ultimately, when something becomes so difficult to reuse, that it's more code, to reuse it than to write it from scratch, you kind of lost the purpose at that point. And that's what I find often happens with Java projects. You try to make them really generic, and by making them really generic, you create these really complex systems that can, solve every problem, including the one you might have, as opposed to writing the system that solves the problem you actually have.
Did you actually try and use generics, for example? Because I always think of generics as a good example of something which looks fairly simple on the surface, but actually is quite complicated once you start getting into it.
For sure, right? Like it's a good example that you can get a lot of complexity there. But I think like in a language, like if you do have a statically typed language like Java, generics are a good idea, right? Because the alternative is something like Go, where you end up just writing the same code over and over. So this is potentially where, again, like dynamic typing actually is an easy way to solve a problem, right? Without introducing mental overhead. But I think like in Java, like it goes far beyond generics, right? It's just like all the patterns you have and also the shared mutable state. It's something you don't even realize that's a problem until you use something without it. Because if that's the only way you write code, you don't. It's kind of like telling a colorblind person that's you never experienced color red, and they're like, well, I don't know what I'm missing, right? I bet, yeah, right. And I think, right, like for me, it's just the complexity kept growing, and I felt literally exhausted working with Java. Like for a while, I was actually thinking of switching careers because I was not enjoying what I was doing. I felt, right, like I really felt like I was exhausted and I wasn't getting anything done. And I had absolutely no time to do any side projects, right? Like I'd go to work, I'd write my code, I go home, and I would not want to touch a computer. I would not want to write code. And after a while, I started thinking about it, and I was like, okay, what are other people doing, right? This can't be the only way you solve problems. And the other thing that was on my mind was the fact that kind of like Moore's law is kind of peaking, right? And we started moving towards multi-core architectures. And I knew I was not smart enough to write multi-threaded code in an imperative language. With threads and mutexes and locking, I can manage 2 threads, maybe 3, but that's it, right? So if you're looking at the world where multi-cores are going to be the norm, and you have 8, 16, 32 cores.
Did you ever read the Java concurrency in practice book? Because that is that's what Rich Hickey reckons was the kind of motivation for him to
write
the language.
I mean, it's been years, but yeah, I think I've read that one and a few others, right? And I was like, I realized, this is something I want to be able to do. And I just I couldn't practically see myself doing it. I'm not smart enough to do that. People who are kudos to them, but it's not me.
Yeah.
And I was like, it gave me motivation to look, is there other approaches to deal with concurrency? And the first actually functional language I looked at was Haskell. I did kind of a bit of a review, and Haskell seemed to be the most pure, the most functional one. I was like, okay, you know what, I might as well dive into it. And I really enjoyed it, right? Because it was a real learning exercise. All of a sudden, I wasn't just kind of learning new syntax or learning, some new libraries or APIs. I was really learning to code in a different way. And it was a mix of being frustrating and enjoyable because on the one hand, you kind of have to throw out everything you know and just start from scratch. But on the other hand, it's a really rewarding experience because you're really learning something new. And once you spend some time with it, you really realize the value of that approach, right? And Haskell completely sold me on functional programming. And for a while on static typing as well, actually, to be honest. I was one of those people telling people that, types are the solution to all your problems, it compiles, it runs, and so on. I've been there, I've done that. I've since gained a bit of a more nuanced perspective on the matter.
We've got it here, guys. We've got it in one tape saying this.
I have changed my perspective. And you know what? I don't think static typing is not valuable, right? I do think it has its own value, and I think it has its trade-offs. And my main issue with the way static typing is presented is not with people advocating for it and saying it's valuable. That's perfectly legit. My issue is with saying that my way or the highway, right? That's if you're not using types, you're being, unethical, or you're being lazy, or because we don't have any evidence for that. And at the same time,
just before we go there, let's just you were jumping to Haskell, you were preaching the benefits. What changed your mind about that to bring you into Clojure?
Okay, yeah, that's actually a good segue, right? Because what happened was I used Haskell, I liked it, but I also realized, realistically, I wouldn't be able to use Haskell for work. And JVM is what I'm familiar with, and I'd like to keep working with a JVM. So my options were basically Scala or Clojure. And I kind of played with both for a while, but what I kept finding was that, and it was kind of funny because originally I was like, oh, parens, it's just so many parens. And especially coming from Haskell where you have no parens, right?
Yeah.
I was like, wow, well, this is ugly. But at the same time, like playing with both Scala and Clojure, what I found was I kept constantly looking things up in Scala. Like every time I'd open the editor, I'd have to Google and figure out how to do something. And even after using it for a few months, I'd still be doing that. Meanwhile, with Clojure code, that just wasn't happening. And part of it was the fact that I had the REPL, and anytime I was confused, I could just run the code and see what it's doing. But the other part was there was just the syntax was so simple and regular. And that kind of like, that was a light bulb going off in my head, realizing that you can have this like stupidly simple syntax that's extremely expressive and extremely flexible. And all these benefits that you get from like structural editing, being able to serialize it easily, being able to use macros on it. And it just, you don't think about the language. And like the more I used Clojure, the more I realized I was thinking about the problems I was solving, not the language. And that meant, I could use that brain power I was using to think about types, about syntax, about, all the different ways you could do things in a particular language to actually focus on other things, on things that was of interest to me. And language kind of became incidental. And I think that's the biggest value of Clojure for me, is that it's incidental to me. Like, I don't think about Clojure when I work with Clojure. I think about my problems. And Clojure is very small and gets out of the way.
So given that now we have this new languages coming on JVM, for example, I see a lot of tweets around about ETA, the Haskell on JVM. Yeah. So what do you think about that kind of approach? Because you say JVM is the biggest reason why, because of the familiarity, because of the libraries and all the stuff available. So what do you think of, these kind of languages, or at least ETA?
I think they're interesting. Like, I think it is a really good approach, and especially considering it's able to leverage existing Haskell ecosystem. Like, you kind of get this language that can both leverage Haskell and the Java ecosystems together, which is really neat, right? And I do think statically typed functional languages are worth exploring, and Haskell is a well-designed language. And given options between like Haskell and Scala, right? I definitely would prefer Haskell myself.
Of course, yeah.
But I also like languages like Elm that like take it a step back from Haskell, where they went with strict evaluation versus lazy. And I do think like it makes it easier to reason about. So, yeah.
So how long have you been doing Clojure now?
About professionally, probably for about 8 years. And I started using it like very early, like probably 1.0, so about pretty much since it came out. Yeah. Like even before it became viable. And that's actually how I ended up with Luminous, right? Because when my team started using Clojure, there wasn't really an established web ecosystem for Clojure. And we actually ended up writing our original project that's still in production now using servlets. Because we were all familiar with the Java ecosystem, we knew how servlets worked. So we're like, okay, like the strings thing looks kind of cool, but you know what we're doing. But eventually we switched to Ring, and we realized, like the effort of putting projects together was kind of non-trivial. And we wanted to have a template that worked for us, and that's kind of was the origin for the Luminous template.
Yeah. So, because in one of the things that in the Clojure world is that, we are, or at least the community is against the frameworks, and then we pick, libraries together. Of course, first of all, Luminous is amazing work. Nowadays I don't start any project without Luminous anyway. So awesome. I just keep adding all the things everywhere, and then just, even for if I want to do something, I'll just generate the template and then see how you build the template, and then just pick the parts that I like. So that was very, very nice. Extremely useful and extremely, beginner friendly, even for the dumb idiots like me. So if you, so coming back to the Luminous part, because, finding the right libraries and then making sure that they're working together. So how do you feel about that problem in Clojure?
I think it is a legitimate problem, right? Because I kind of agree with the notion of not using frameworks and using libraries and composing them, having the user having the power to just decide how they want their application to be structured. But the gap there is, unless you know the ecosystem well, you can't really do that effectively, right? So if you're a beginner and you're just coming to Clojure and you're like, okay, how do I build a web app? Well, just go look through all those libraries, figure out which ones are still maintained, put them together, and good luck. That's not really realistic, right? So we kind of need this middle ground, and I think templates do provide that, where somebody can put things together for you in a workable state, You can run it and focus on actually doing things you find interesting, and then learn things as you need them, right? Maybe you want to swap out a templating language or a JDBC library or something. And then you kind of figure out where it's hooked up, and hopefully it's not too complicated, and go with it, right? So that does seem like a good approach to me. But I don't really see the value the frameworks provide over libraries in principle, right? Because especially in Clojure, where libraries are mostly data-driven in terms of API, it's very easy to pipe them together, right? Like I get a library, I see what shape of data it returns, maybe I massage it in a trivial way and pass it to another library. And it's very easy for me to build up my application that way. Whereas when I work with a framework, I kind of have to buy into the whole opinion of the framework and how it wants me to solve the problem. And it works really well when I'm solving the problems the way the author of the framework thinks and envisions the solution. But it completely falls apart as soon as I need to step sideways, right? Because then you have this whole inversion of control happening. And I don't find that's helpful because it leads to this indirect code that's harder to reason about. But I think like we could have more higher level libraries in Clojure. For example, and it's just I haven't had the energy to do it in Luminous, but like one example would be something like authentication. You could have a library that manages, registering a user, logging in a user, like doing all those things, and just initializes with a map where you give it the roots you want to use, and then give it the functions that actually handle the specifics of authentication, persistence, and loading the users. And then you just plug this library like a module and off you go, right? And again, you can do this without using the framework. You can just have smarter, bigger libraries that use other libraries internally.
What do you think about, because friend and buddy are meant to do these kind of things?
So I think like I would love to see that, right? I think that might be the way to move to a next level of making Clojure apps easier to build, because it is true that the initial stage of kind of putting the little pieces together is a bit tedious, right? Because you have to do those common things every time you build a web app. Setting up authentication, setting up your users, setting up the database, and so on. And Luminous solves some of the most painful points of that, but I think you could go a lot further and be more opinionated.
Yeah.
And I think
but we do have friend and buddy, as Ray was pointing out, right? So what do you think of those?
Well, actually, I use buddy in Luminous, right? But I do find it's still like fairly low level. And it's a good example that we have a lot of these libraries that effectively do the same thing, right? They have slightly different APIs, and that's only there's no fundamental difference between them. And we have a lot of that happening in the community, right? And I would really like us to move past making the simple libraries that kind of like solve a problem that's already been solved and start moving towards building more interesting libraries. Just like pick a stack, maybe not, it doesn't have to be the ideal stack, but just a stack that most people use, right? And just say, okay, that's the stack we're using, that's what's popular. Let's just accept it and move on. And not keep trying to reinvent it.
That seems to be... I think that's a really nice argument, but the thing is that maybe this is something. Of course, everything is personal opinion in this podcast, so I don't need to put that disclaimer up front. So that what I find in Clojure, for example, if you see all this React-based templates, not templates, the libraries.
Right.
So there was one library comes in, and then there is like 20 other React Clojure script things show up, and somehow. It's a nice thing because everybody differs in a small way or something, but in the end, it's. I think somehow the community gravitates towards at least one thing being that thing. Otherwise, we have Rum and Quiescent or whatever. I mean, whatnot. There has been like 20 or 30 ways of using React in Clojure script programs, and now pretty much everything is reagent, reframe, or at least that's what the community has settled on.
So I think it does, It does happen organically, right, that people gravitate towards a specific stack. But I don't want to discourage people from also, right, like experimenting and trying things. But I think it would be nice to have kind of this official almost stack to say, like if you're not sure and you're not trying to experiment, you just want to get work done, here's what you should use, right? And the value for me in that would be that maybe we could, a lot of libraries right now are run by individuals, right? Like even Luminous is mostly individual effort by me. But I really would like to see it more driven by organizations and community, right? So you have a bigger buzz factor. And then once you have this one stack that's popular and a lot of people are contributing to it, it's easier to do bug fixes, it's easier to do maintenance, and the work gets amortized across more people, right? Because it is a lot of work to maintain open source projects. And it's hard to fault people, right? Like often we kind of get upset that people abandon their project, but it's like, it's a lot of work. Like, and they're doing this on their free time usually.
Isn't that the Clojure way, though? I mean, Clojure itself seems to have a bus factor of 1, so every library should also. That's a joke, by the way. I know Alex does nice work, and the guys do work on it, so yeah.
But yeah,
just before I get the flame mails coming in.
We'll never get Rich Hickey on this podcast.
But I think it is like necessarily a problem with smaller niche communities, right? Because we just have less resources to work with. It is what it is. But we can strive to improve.
I think it's the trick. I mean, to sort of Vijay's point about personal opinion, I quite like the idea that problems are never really solved. Because I think that they rarely are actually. And an example I sort of just thought off the top of my head is there's this whole component system thing that started with Stuart Sierra, and then we have the guy
Mount.
from Toilers who did the Mount stuff, and then we've got Integrant from James Weaver, and we've got various other ones. And I think, and what they're always trying to do is they're always trying to say, well, where is the actual heart of the problem here? Where is the, and what is the API? How are we trying to empower users to do something that is more I think we're still trying to find what is idiomatic in the Clojure community. And I think that's quite interesting that even what is really idiomatic is still just isn't really settled law yet,
Yeah, no, I agree with that completely. And I think, I've seen it change dramatically, right? From 8 years ago to now, how people use it and what people do. So there is definitely value in exploration. But at the same time, I would say, right, just by sheer act of using Clojure, you're so far ahead of most languages, right? Because the language, it's true, right? Just by sheer act of having a mutable language that's simple and consistent and it's very stable. It has a large ecosystem and can rely on, right? All those aspects, for example, if you're working with something like Node, right? Building a React app is way more work than building a reagent app.
Yeah.
In many, many aspects, right? So just by picking Clojure, you're just solving all those problems. And partially,
but hey, I mean, you get if you use Node, you get 1 million libraries, though. 1 per every line. So.
There is that. Not necessarily a good thing, but it's definitely an aspect of the ecosystem. But the worst part is, right, every one of those libraries is going to be packaged differently, using different tools and different testing methods. It's its own little garden, right? And that's very frustrating because when you try to put those libraries together, they all do different things. And I think that's another part of Clojure, right? Because in a lot of languages, they're trying to add same features as Clojure, JavaScript best practices look very similar to ClojureScript best practices. But the problem is you're kind of bolting this onto existing ecosystem and language. And that means your language is getting more complex and it's getting bigger. And when you see projects, now you see lots of different styles. Right, you can open a JavaScript library and see callbacks, promises, and async code all in one library. And it just shows how that library evolved over time, right? Whereas Clojure be saying, this is how we're going to do things, and being opinionated from ground up, and having all those novel ideas from the start means the code tends to be a lot cleaner, and you have a lot less decisions to make about how you're going to do things.
Yeah.
I think the other side of that, though, I guess, is that things like JavaScript and Scala, to some extent as well, is that you end up with people having kind of opinions about what is the right way to use this language, and then that becomes a kind of optimized locally for those teams. And then if you join that team and you happen to be more of a functional programmer than an object-oriented programmer, or you happen to be more of a Scala Z programmer than a standard Scala programmer, let's say, then everything kind of breaks down, Or if in the JavaScript world, if you want to use immutable JS, then you're kind of on a small edge of the community. It's definitely not the default. Anyway, my point is that it's kind of down to developer discipline in languages, especially like JavaScript, rather than being the default like in Clojure.
Absolutely, right? And the problem with that also, right, like if you're using, even if you're not working in a team, but say use a library from somebody, right? Every library has its own flavor and its own style, making it much harder to understand how they work and how to use them effectively. Whereas with Clojure, it's like it rarely happens, right? Like I've read many libraries because the documentation is not ideal often. So you end up reading the source. And I find it's really easy to just sit down and read through a Clojure library and understand it fully, which I have trouble doing in a lot of other languages, right? Like I've literally never contributed to a single Java library, even though I use it for a decade professionally. All right? Because like every time you look at it and you're like, oh, this should be an easiest thing to fix. And you open the project and you see like a million classes in it and you're like, yeah, I have other things to do right now. So.
Yeah.
But so if you're talking about, of course, there is a lot of complexity, but seems like, JavaScript became like the language where everybody can jump in. And I know, you've been, of course, you participate in a lot of discussions where you're leading a team and you bring up the idea that Clojure is very easy to, get started with for beginners. So how do you see the contrast between these two then?
Well, I think
for beginners,
right. Well, I think like the reason I think JavaScript is popular is just because, right, like anybody can open the browser console and start writing JavaScript. Like the barrier is literally zero. It's not there. You open the text editor, you open browser, off you go, right? So that obviously makes the language incredibly popular and incredibly accessible. And I would say this is the biggest barrier for Clojure adoption, is that it's not easy to get started with. And the caveat there is, if you're starting on a team that's already using Clojure, or you have somebody to mentor you who knows Clojure well, it is easy to get started with. Because they'll just point you in the right direction, tell you what tools to use, help you out with any initial problems you have, and can be a really great experience, right? But if you're just starting on your own, and you don't know anybody who uses Clojure, it's really daunting. Because even in terms of editors, like your options are either Emacs or IntelliJ.
Nothing else,
And they're both complex, right? Like once we learn those tools and internalize them, they're amazing professional tools. But if you just want to play around with Clojure, it's not great. It's not like, popping up like VS Code or Atom and off you go. And the things that make Clojure nice, like the REPL, people don't even know about them, right? So even though you have this REPL, you have this nice tool, in practice, most people don't realize they can use it, especially from the editor. So you can recompile their applications and see that it takes, like a minute to compile and go, it's like, this language is garbage. Like, what am I doing, right? So
what is your program for onboarding new developers into Clojure, and what is their experience generally?
So that's interesting, right? Because my team hires co-op students quite regularly.
Yep.
And they're straight out of universities. They've never seen Clojure before. They've rarely seen functional programming, or like very superficially with maybe a course on Schema or something. So we kind of developed a program basically where we use Clojure Distilled just to get them to read through on the first day. Then we get them to play around with a few workshops to do kind of like reagent apps, read through Brave Clojure, and start throwing them on our projects like literally within a week or two, where we have like small bugs or something, and we give it to them, and they try to solve it, and they make a pull request, and somebody sits down with them and reviews them. We do a bit of pair programming. So in general, we find it's really easy to onboard people. Like within a couple of weeks, you can get somebody who's never seen functional programming and get them to write useful code. And caveat being that you have experienced people on team who can set them straight and help them out when they get stuck. But for a lot of applications, right, like I think there is also a difference, right, if you're solving problems like on Foreclosure, where you're trying to figure out how to do puzzles, versus writing real-world apps, where a lot of code is actually fairly straightforward. You're just moving data around from A to B and massaging it in some way. And that's like 90% of most web applications.
Yeah.
So
what is your stack generally? I mean, the kind of stack that you use. Of course, I'm pretty sure you're using Luminous everywhere. But Luminous comes with all sorts of plugins, right?
Right. So we use Luminous. We use Postgres for data store primarily. We use Reframe on the front end. We recently actually started using keyframe.
Yeah.
Because we find it the way it handles routing is kind of nice with the controllers, and we are using Retit now for routing because it works on both client and server. So it's really nice to be able to have, like, especially if you're doing SPAs, it's handy. And it's kind of like really nice and batteries included. So it provides us stuff like Swagger out of the box. It introduces interceptors for Ring, which is really handy. And that's basically our stack. So we actually use Lumo for deployment scripts because we use Kubernetes. So we generate the JSON for the Kubernetes from ClojureScript. And a friend from work actually recently published an open source library called Viewer that kind of basically he extracted from the stuff you're doing for making these little scripts for driving Kubernetes builds. We can link it maybe like in the comments later or something.
Yeah.
So that's basically our stack.
Okay. So what is the most difficult thing? Because I think we bashed enough around about the error messages on this podcast, and now we have one alpha that is trying to fix some of the issues already. So what do you think of the state of that problem that we have as as Clojure team?
Yeah, I think I definitely do think it's a barrier for beginners because, right, like first time you see a Clojure stack trace, it's a bit daunting. I also think you quickly realize that it's actually not that bad, right? Because of the immutable nature of the language and the pure functions, usually the error happens to be on a line that's the last line of stack trace. So you just like scroll down the line, even if the error is meaningless, you go to that function, look at it. And if you're writing reasonably short functions, it's pretty easy to figure out, oh, I did this or I did that, right? And you have the REPL, so you can try it out and see what happened, capture maybe some inputs. So I don't think it's as big of a problem as people make it out to be, but at the same time, I think it could be improved. And I'm really glad Cognitect is now taking it a bit more seriously. And it looks like they're trying to make tools for making their reporting nicer. I do think spec in general, like especially the concept of spec, is really great and really useful. Because I do think like you should be validating your data at the edges, and spec provides a nice way to do that. And then, once the data is in my business logic, I don't think I should be validating that problem, right? Like I can assume that's already been sanitized, and by the time I start doing business logic, it should be in good state. So partially like structuring your applications in that way helps as well.
Yeah.
But also I think spec could be improved in terms of API. Because I feel it's its own language. And it's very macro-driven, right? Where we always talk about having everything being data-driven in Clojure, and spec is kind of like the opposite of that. So I find there is a bit of mental overhead in figuring out how to write specs effectively and compose them effectively, and it doesn't really represent the shape of the data, which would be my biggest complaint with spec. Right? When I have like heavily nested data structures, the specs for them don't really tell me what the data will look like. And I think that's really valuable because that's one thing I find schema does really, really well. You can look at the schema and immediately tell what the data is expected to look like. And there is a library from Metasyn called SpecTools that we're using at work. And it has a data spec syntax, which lets you use schema-style syntax with spec. But unfortunately, because of the nature of spec, it doesn't always compose well with actual specs, and there's some quirks you introduce. So it's kind of like improve some things, but make some things worse. So it's still not really ideal, in my opinion.
Can you expand a bit on spec being a language and macro-driven thing? So maybe do you have an example in your mind that you can explain the limitation that you're facing with spec?
Not anything concrete off the top of my head, but more like, right, like if you look at the spec, just the public API for it, right, it's fairly large. And it's a whole new set of functions you kind of have to keep in your head that are different from the Clojure core functions, right? Ideally, and like Rich Hickey had like some of his talks talking about that, right? Like he says that one of the biggest advantages of Clojure is that you learn the standard library API, and now you can transform any kind of data using that API. And you don't have to learn new syntaxes and new rules and new semantics for it. But spec introduces that, right? It does have its own semantics and its own rules and its own set of functions you learn. And if you're using them day to day, it's not really a problem, right? But if you use spec sporadically, you're always going to have to come back and look into the documentation for it and figure out how to do things.
I think some of the words that they've used are a bit, I mean, again, it's like any opinion, but I think things like spec/cat, for instance, to say that, this is some sort of array of values seems weird to me. So words like that, it's not natural. I don't see that in any other function of Clojure.
Yep.
So those are the kind of things that I kind of think are a bit weird, because I can see, like you say, you have spec and spec or, which is, well, yeah, okay, I see what you're doing there. Because you have to have your own version of the ands and the ors, I guess. Bit of a shame, but okay, you have to do that. But then cat, where is that coming from? And multi is more obvious because it's a multi-method. But there are various ones which seem like they're a bit disconnected from the standard syntax.
Yeah.
And that seems just puts me off a little bit.
That's a good way to kind of like sum up the issues I have as well, with some concrete examples there. And that's a problem like I've never had using schema, right? Because with schema, it's all data-driven. So now, if I need to compose schemas or modify them, I just use regular Clojure for that. So there is no extra language to learn. And I really I do think you could have schema-style syntax using spec semantics and getting the spec benefits. And I really would like to see completely data-driven syntax on top of spec. Hopefully somebody maybe data spec and spec tools or something matures enough where you don't really see spec.
Yeah.
I think that's very likely to happen, actually. I think because inevitably there's going to be some tooling on top of spec from the community. And we use those Matosin tools as well, and obviously those are great guys. They're doing awesome work there. But it's like you said, it's a work in progress. I think one of the problems for me with spec is that we're 2 years in and it's still alpha, and that's well, come on guys, shit, I get off the pot, So I really hope with 1.10 it moves out of the alpha world into just that is spec, because there has to be some end to this alpha bullshit,
Yeah, no, I agree. And also, if it is alpha, I don't think it necessarily should have been packaged in a core, right, as a dependency of the core. It would have been nice to keep it separate, and then once it's ready, actually put it in language, because Clojure has been really good about not introducing breaking changes, but this will necessarily have a breaking change when they change the namespace, and everybody has to go through and change their spec from alpha to non-alpha. So it almost got, I think, maybe oversold in terms of readiness, because a lot of people jumped onto it, and a lot of people are using spec now, but we don't really know how it's going to change in the future. I remember there was a comment either from Alex Miller or Rich Hickey himself that they're kind of thinking about reworking spec a bit. There hasn't been any details on that, but that could mean anything.
I still remember reading that they were going to make it more programmable, and I mean that definitely will help. To your point about making it more data driven. If it's more programmable, if there are more tools to program, to generate specs and stuff like that, then that would be a good. But again, I don't see how that's necessarily a breaking change. I mean, I think. There's a lot of criminology at the moment, and that's the kind of thing which is a bit annoying about Clojure to some extent, is that, like you say, why introduce it in the core if it's alpha and you are going to break it and are going to change things? Because it's in a lot of code now. It is really in a shitload of code, even all of Clojure,
Right. And I think, that's, Clojure being a Lisp has this huge advantage that we can express most things in user space as libraries.
Yeah.
We don't need to add them to the core language. And to me, if you look at most languages, after a decade of use, they end up with a lot of craft. And if we talked about this earlier, right, that Clojure usage patterns have changed significantly since 1.0 till now. But the language largely stayed the same. And I think it's primarily because we have good metaprogramming. We can do things like core async or Spectre or even Spec as libraries. So, and to me, that's the best of both worlds, right? Because we can try this new idea, see if it works out, people can start using it, and then we get a better idea. Now we don't have to either deprecate something in language and force people to write their code, but we're also not affecting existing projects using this code because they can just keep using the library and they're fine. But now we can move on to something new gradually, right? And the core language, I think, should stay small and unopinionated, right? Because if you have a small core, you can use it in many domains effectively, and you don't have to create a language that's really adaptable to every domain and think up every possible use case for the language. People can create libraries for their use cases. And that's something that's not possible in a lot of languages, or not to the same extent at least.
I kind of had that. I kind of had a bit of to and fro with Alex about this on the Twitters, because I think that Spec kind of has there's a lot of discussion about you don't need to. I think Stuart Holloway says this quite a lot. Is that you just need to write the library. Don't worry about it. You don't need to change the core. And my argument is, well, yeah, but you didn't. That's not what Spec is. Spec is not just a library. Or if it is just a library, well, it's it got a special place because it's a library which always comes with the core code. So I think that if you could have that as an option where you don't depend on that, well, maybe you could put more things into these, strip out the core. Strip out all this string stuff, strip out all the XML stuff, strip out loads and loads and loads of things, and have it all available via deps.eden. That's fine for me,
Yeah, no, I agree with that as well, right? If it's going to be in the core, I think it should be solving the problem holistically. And I definitely agree that something as fundamental as error reporting shouldn't be left up to community will do it at some point, somehow, right? It's too fundamental.
Yeah.
And if Spec was released as a completely separate thing from core, and Cognitect said, okay, here's this neat idea we have, it's contracts, it works to solve these problems, use it and build stuff on top of it, that would be cool too. But because you are kind of recognizing that, yes, this is a problem that needs to be solved in the core language, solve it fully, right? Don't do this kind of halfway thing and go, it's community will handle it.
But I think Cognitect is... It's as you said, if you're using Clojure, you're more interested in solving some domain problems. So I think they're too busy solving domain problems to actually fix Clojure problems. So which makes sense, because the language is too good to solve other problems. So they're too busy with that one.
Yeah, and I absolutely see it, right? Obviously, I have no affiliation with Cognitect, so anything I say is a pure speculation. But my feeling is that they focus on their consulting business, right? And that makes sense, right? Their company, they need to eat. So the problems they're going to address are the problems their clients have. And onboarding and user-friendliness are not that problem because they're going to be working with their clients and teaching them. And that's the thing I mentioned before, my work. Yeah, we don't have any problems onboarding people because we just sit down with them and teach them for a week and they're done and they're good. But it's a big problem for growing a community at large, right? Because it needs to grow organically and it's going to be growing from people who are going to try Clojure on their own. And if their experience is poor, it becomes a really big barrier for adopting Clojure in general, right? I think Clojure script solved huge problems that are still unsolved in JavaScript. And overall, it's easier to use. It's you're going to get your project done faster, guarantee it. But if you don't know how to get started with it, you're never going to try it. So it's a moot point of that, right?
Yeah, that's true. But before we get into next topic, so we've been talking a lot about specs, and there is a lot of discussion between static typing versus specs, right? So where do you see the value? I mean, should we all say fuck it, and then we go to we just wait for ETA people to finish their shit, and then at least there is a company behind it. Their product is the language, so we all switch to ETA, or we should think no, this is still the better way.
I think spec, or at least gradual typing, is fundamentally a better way. And here's why, right? So we'll come back to the whole static typing thing, I guess. So what happens, right? What do types tell us? Types are primarily a tool for telling us that code is self-consistent, right? They're not telling us the intent of the code. And there are languages like Coq, right, like that force us to express a whole program as a specification. But you know what? At that point, your program is written in your types. And who is helping you type check that? Right? You still have to manually read the specification, understand that it's correct, and you can have bugs in your specification. There's like, I think, insertion cert example in Idris that's about 300 lines long. Like, I can write it in dynamic language in under 10 lines. And I'll have much better understanding that those 10 lines of code do exactly what I want than this formally provable 300-line proof, right? Like a good example, another example, right, like from math is Fermat's last theorem. I can state it really easily. I can test it for specific use cases I have really easily. But a general proof, there's maybe like, a handful of people in the world who can understand it. And a proof that you can't understand has no value. And the thing with static typing is that you end up being restricted to a set of statements that the type checker can verify, right? And every other statement, whether it's correct or incorrect, has to be thrown out, right? So that's kind of the limit. You're writing code for the type checker, not for the human reader. And a human reader can learn to think kind of like a type checker. But ultimately, right, like you're not writing code for people to read at that point. And the problem is like, right, like with simple examples, people always say it's like, oh, you have type inference and HM, you never have to write types. That is not the issue. The issue is I have to structure my code in a specific way now, right? Like in Haskell, I can't just put a log statement somewhere in my production code. I have to design my core application around pushing the side effect to the edge so it can be expressed via monad. And that's why monads are so prevalent in Haskell as opposed to any other languages, because that's the only way you can solve like this problem, because side effects are tracked by your type system. And there are benefits to that. I completely accept that, right? There you get some guarantees you wouldn't get otherwise. But those guarantees come at a cost, and the cost is that now you're structuring your code in a specific way. And in cases where this makes sense, like a compiler, for example, you're probably going to structure your code the same way anyways, right? So there's no kind of like additional mental overhead. But in a lot of real-world applications, it's not the case, right? And then your code becomes more convoluted, and now the compiler tells you it's self-consistent, but you don't know that it's doing what you want it to, right? And so it's like, well, I know it compiles, I know it runs. I'm still going to have to write tests or provide specs or do something like that to know that it's really doing what was intended. So it doesn't obviate you from that need. And I think spec provides this really nice middle ground because you're literally providing a specification for what your program is meant to be doing, right? And by writing the specification at top level, you're kind of guaranteeing that all the rest of the code is doing what it's supposed to. You don't need to provide a spec for each individual helper function. You just need to provide it for your API. And once you have tests and specs on your API, you have really good guarantee that your code is doing exactly what you want it to, right? And that's why I don't see it as a real problem in the functional language, at least.
Do you think that there will be like an advantage to a language where we can specify the types at the boundary, but within the core, we don't need to have statically typed system?
Potentially. I mean, that's kind of like where gradual typing systems try to go, right? But I think like you could go even further. Like I really like approach of Erlang dialyzer, where it's a linter, right? And what it tries to do is it looks for code that's obviously incorrect, as opposed to trying to prove that it is correct, right?
Okay.
And I think like if you think about closure code, right? Like if you're working with immutable data, each time you do a function call and you pass some data in, you can treat it as a binding. So you say, I passed in a map or a vector or whatever, and it had those values. Okay, now I know it had those types. So as I navigate down the tree, I can kind of track those types. And whenever I use it incorrectly, I can notify the user that, hey, you had a map and you tried to do something on it.
Yeah.
I don't know if you've been watching Mike Fikes recently on Twitter, but he started to put some doing some work on type inference in ClojureScript, where, you can, if you're going to do like an inc operation on a string, then he can tell you that that's a failure.
Right. No, that's exactly a perfect example of that. And he's done some amazing work on that regard, right? And there was a recent talk from Andrew, I forget his last name, the guy who works on CLJS time. And he talked about doing like a similar kind of system as a library for Clojure. And I think that would address, honestly, like 90% of annoyances with type mismatches in Clojure. Because, the linter will be able to quickly tell you, hey, you use this, you meant to use that. And there's going to be that, maybe like 10% case where just it's undecidable and could either give you a warning or just leave you alone. And then you'll have your specs and tests, which ultimately I think are what's really telling you that your code is doing what you intended, right? And there's no shortcut for that. And I think that's, for me at least, right, that's a real issue, right? Like, types don't tell you the code is correct, and they can only help you pretty much as linter, or just in a different way, right? They give you a different set of guarantees, but they're not guarantees about your code being correct. And I think that's a really important distinction.
I think the way I look at it as well is that the joy that I get from Clojure is the fact that I can use the REPL and I can just start like evolving a program from some simple data structures and some simple like calculations about what this thing means versus that thing. I don't need to type anything. I don't need to know what the types are or anything. I can just do it from data structures and from data and from, function composition. And I think arguing about types, you kind of lose this piece, which is the fact that you can just program something. Because that's really the win that we have with Clojure, I think, is that you can just program something really nicely. And then you can decide whether or not it's appropriate to put some types on top later.
Yeah, I absolutely agree. And like to add to that, like I find in many cases when I solve a new problem, I don't know what the solution is going to be. So I don't know what the types are because I might try different approaches. And like you said, when you try it on the REPL, you can try this or try that. And I find like often I'll gain understanding of the problem by solving it. And then I might completely throw away the original solution. And now that I know what I need to do, write a completely different solution for it, right? And the types kind of, they prevent this kind of thinking, I find, right? Because now you have to think about your types first, and you formalize the thing. And now you kind of fill in the blanks, right? But if I don't know what the thing is, how can I formalize it?
This is the thing to me, is like, looking from a types perspective is just looking at it's like you've got the wrong end of the telescope. Yeah. Right.
And I mean, like to do a bit of kind of like a digression, right? I also find it interesting, like the discussion about types. To me, it feels like people are putting the cart before the horse, because even in studies, like there was a recent GitHub study, right? Like on whether dynamic typing or static typing is effective. And that's already too early to have this discussion, in my opinion, because what you should be really looking at, let's look at a whole bunch of projects on GitHub, compare different languages, compare like large numbers of small, large, all kinds of projects, and see if you see trends, if you see statistical trends between languages, right? And then let's say we see that statistically Haskell projects have less defects than Java projects, right? Like people open less issues, updates come out more often, whatever, right? Then we can make a hypothesis and say, well, maybe the Haskell type system is what's the driving factor here, right? That's the difference. Then we can set up some experiments around that and say, okay, let's test this hypothesis further, right? But the opposite happens. People say it's like, I think types are really useful and that's what's solving the problem. And look, now let's try to prove that types are what's solving the problem, right? It's circular.
But I think that there has been something like this. But there has been something like that research, right? And then it was inconclusive that having types or no types are going to give you any benefit or not. So
well, for sure, there's still a lot of. I think Dan Liu has like a whole page of all the existing research, right? Exactly, right? Like it's been around for 50 years, and we still are saying it's like, well, maybe no. Like at some point you have to say maybe if there is a difference, it can be very significant.
Yeah.
I think part of the problem is that it's very difficult because what you tend to find is that like certain languages like JavaScript, and maybe it's even Java as well, is that you've got a broader spread of like programmer skills and programmer experience. And it's very hard to factor that in, because often, and with this is a joke about Clojure, that you tend to get, kind of more experienced programmers, and Haskell, you tend to get more academic programmers, more mathematical programmers who maybe are a bit stricter, and their code may be actually better than just in a sort of inverted commas. They might be better programmers because it's a smaller community and very self-selecting. It's very difficult to factor out those kind of human factors over the type factors.
Right. But I think by that logic, we should see even bigger difference, right? Because if you're saying more experienced programmers are using functional languages, static typing, like in this languages, the code should be way better than languages that are used by beginners and intermediate programmers and so on. But we're not seeing even that, right? Like even in these languages that are used by very advanced developers who know what they're doing, we still don't see the benefit, right? Or at least not a large benefit. And I think another thing, before I forget, is like we've seen this with object orientation, right? Like it's been sold as a panacea, right? It's going to be code is going to be reusable. We're going to reduce coupling. Like we've all heard that. Everything is natural to model as objects. And what turns out, smart people can make things sound really, really good on paper. You can, like if you're a smart person, you can rationalize anything and make it sound great. That's why empiricism is important. Right? Like if something sounds great, but it doesn't pan out to be great, we'll know empirically. But if you have those discussions around, it's like, well, on paper, this sounds really, really good, and we should all just dive in and use it and forget every other approach, that can have some repercussions, right? And like after 20 years of use of OO, we're now realizing that a lot of those benefits have been oversold or non-existent. And I feel like we have the same kind of atmosphere with static typing right now, where you cannot question the value of static typing, right? You're immediately considered to be ignorant, or you don't have the experience to talk about, or you just you just don't get it. And no, we have to have...
You're unethical.
Exactly, right? You're unethical.
Oh, so man, let's get into that one. Come on. I mean, Jesus Christ. Why is this happening? Why are people trolling us this badly,
I feel like it's the sunk cost fallacy, right? Because to get proficient with Haskell, you have to invest a lot of time into Haskell. And once you invested all this time, it's really hard to say, well, maybe the benefits aren't great, right? Like I spent a year learning, and you see it like from people literally say it, right? It's like, oh, how long have you been using Haskell? Oh, yeah, that's nothing, right? Once you use it for a decade, then you start seeing benefits. It's like, really?
It's like Brexit.
I might not be programming in a decade. Right? So it's like, like when you make this big investment, it becomes kind of like, people buy monster cables and, they can hear the difference. Well, yeah, but empirically, in a double-blind test, maybe you can't. So I think there's a bit of that happening, right? And people obviously get offended when you start suggesting that maybe this approach isn't as effective as you claim it to be. And I think, right, like my position is, it's not that static typing is not effective. You're right, like maybe it is. And I'm willing to say that maybe for some people it's way more effective. Right? But like not everybody thinks the same way. Not everybody works in the same domain and solves the same problems. And until we know definitively that one approach is strictly superior to the other, we should be exploring both. We should be encouraging people to build systems and languages that explore all different kinds of approaches, not just saying it's like, okay, that's it, that's the way we're going to do things.
I think the unethical thing to me is in itself an unethical approach, though. Because, just to go meta, as we like to, because I think if you say that something is unethical, then, you're shutting down discussion, you're shutting down, and you're basically saying, hey, all these life support machine systems, everything that's kind of important to us, should be ripped out and immediately replaced by this system that I love. Because everything else is literally against, the good things that humans need. And that seems like a hell of a claim,
for sure, right?
Everything else is literally unethical. It's literally should be torn down because it's offensive to human health. That seems that's a hell of a claim on no evidence,
Yes, right. Like, and that's a problem, right? Like, if there was like concrete evidence that just static typing reduced defects across the board, statistically significantly, right? Yeah, okay, I can buy the argument that if I'm making a medical system, maybe it is unethical for me to use something that could potentially introduce defects that I would have caught otherwise. But when you have no evidence for that, that's a really wild claim, right?
Yeah.
I think we should go in the other direction completely. We should say something like, if you're using static typing, then you're causing global warming or shit like that.
Yes, exactly.
Yeah, I mean, your compilation cycles are actually causing global warming. You should use dynamic languages. So, there is only one compiler running. You only run bytes of code. So, save the planet, use dynamic languages or some shit like that. I think we need to start this propaganda. If using dynamic languages is unethical. But there is an interesting thing, though, because I've been working with a lot of Python code these days because of machine learning, interacting with the data scientists and everybody. So, I mean, it's fucking horrible. I mean, it's the problems that they have are magical. I mean, there is no, a standard tooling for dependency management. They're just waking up that, we can build larger programs with Python. So let's get started with all this shit. But the same problem exists in Clojure as well. If you think about refactoring, right? So how do you cope up with that one? Because this is, let's keep the whole less bugs bullshit aside. Maintaining code base over the period, which is having types versus maintaining code that is like Clojure or Python. So because you've been involved with a lot of projects, so how do you see this thing play out in Clojure?
So I think, like, for me, the biggest tool for maintaining large projects and reducing complexity has been immutability, right? Because if your data is immutable and your functions are pure, the scope of things you have to keep in your head to work with a particular function stays constant, right? As your project keeps getting bigger and bigger and bigger, if I open up a file from 6 months ago and look at the particular function, learning what it does takes the same amount of effort as it did, when the code base was
But isn't that an argument for type system, though? Because then you are not type system, but probably languages like Haskell, where you are essentially forced to write pure functions.
I don't think so, right? Because if you understand why you need to use a language like Haskell, you understand how to structure your code in a way where a majority of code is going to be pure. Right? And if you don't know better, you're not going to use Haskell anyways. So it's a moot point. But I do think, right, like, I literally treat every namespace on the project as its own library. Right? You don't have to split your project, like, physically into multiple libraries, but it is helpful to think of each namespace as a small library with a small API of maybe a couple of functions at the bottom and the rest being helpers. And your whole project is, like, structured of the small independent components that can be reasoned about individually, right? And you grow this bigger and bigger, and I think the idea is to try to write as much declarative code as possible, where you just have these pipelines of transformation, and then you can reason about those, and you don't have to reason about the details of a library. Like, for example, if you take a library like CLJ HTTP, it has a ton of code in it, right? I don't ever worry about the code inside of CLJ HTTP. I just worry about its API, because I pass the data and I get data back. And that's predictable, right? And that's a boundary, right? And then again, that's where you can put specs or schema or something. And I find if you use this approach, growing your code bases is not really a problem in Clojure, right? And this is a dramatic change from imperative dynamic languages like Python or JavaScript, where everything's coupled via state, right? And at the same time, you're creating types, because this object-oriented languages encourage you to make a lot of types. So now you've created this problem of having a lot of types, and language isn't helping you manage it in any way. So of course it's difficult, right? And I think like a lot of pushback against dynamic typing comes from people who use this kind of languages, and that's their only exposure to dynamic languages. And it's like, dynamic typing is like way on the bottom of the list of problems in these languages.
Yeah, that's true.
Right? I'm wondering what you think. I mean, this is like maybe it's because it's a kind of like web thing. With APIs, do you think that there's a tendency in it? I mean, I've seen it myself anyway. There's a tendency in APIs to kind of get a bit objecty. Even in the Clojure world, that you tend to do things like, you have like a client or you have, a particular service. It's the REST APIs tend not to be very composable,
Yeah, and I guess like that's almost like a natural place for this kind of like objective things to arise. I mean, like people are trying to do different things with stuff like GraphQL, for example, right? Where it's more like a query. But I don't think that's necessarily problematic at that level, right? Because often you will, like, at least like the code might seem the way we structure it is, APIs tend to be fairly stateless. So most of the logic that deals with state and UI state specifically moves to the client, right? Because you can like in this SPA style, in a reframe DB usually for us. And then we just make this service calls to do, get a query, get some data. So in that sense, it's not really object-oriented because we're not keeping state on a server. But you naturally do group, I find, functions almost the same way as classes, right? Because a namespace becomes kind of like a class with all static methods in it. And it's a really nice way to think about it if you're coming from object-oriented programming.
Yep.
And I don't think that's necessarily wrong, right? Like, obviously, there is appeal to object orientation because it is popular and people find some aspects of it intuitive. So we shouldn't like throw the baby out of the bathwater either. In cases where it makes sense, let's use it, right? That's fine. But it's just in most cases we don't really need it, and we should strive to have code that's data-driven and functional.
So looking a bit into the future, so 10 years or more Java programming, and then almost 10 years or almost nearly 10 years, maybe even more. 10 years. Of course, you're not. I hope you're not writing Clojure before Ichiki. And so where do you see? I mean, are you picking up any other languages or some trends that you think that are going to be useful in the web or in the domain that you're working in? Like Rust or any other languages?
It's kind of funny because like I looked at other languages once in a while, but I just don't see them introducing anything fundamental. Right? Like it's different flavor, but a lot of interesting things end up in Clojure really fast. Like things like core async from Go channels, right? Or reframe and reagent are good examples. Like a lot of the stuff gets to Clojure pretty fast, and the best part is you can like do it yourself in Clojure pretty fast. So I don't really, like, a language would have to introduce something really fundamentally new for me to actually consider moving to it. And I'm just not seeing it, right? And like, we really haven't seen it since inception of computer languages, arguably, right? Because Lambda calculus came out pretty early on. Yeah.
That's the thing. I think we're all going back to 1959s again, and then writing Lisp again. Just so what is so from the point of community, so what do you think about Clojure? I know you're extremely active in Reddit and all sorts of places, and you wrote almost I think the second edition of your book is already out.
Also,
right?
I have exciting news. I am working on the third edition. I'm doing it.
Cool.
Joined this time with a friend from work. So
nice.
We're going to update basically everything to latest and greatest, but we're also introducing Reframe, which I didn't really talk about before. We're going to focus on Redshift instead of Composure, and like a lot more talk about SPAs and hopefully Electron and React Native if we get to it. So what we'd really like to show with the new edition is that you can use Clojure full stack. Like literally, right? Yeah. Like from shell scripting to server-side work to web apps to mobile. You can just list one language and not worry about it, right?
One ring to rule them all.
That's right.
One parenthesis to rule them all.
Hopefully the 1% argument is coming sometime in the year next year.
But...
That's right.
Look, I mean, I don't need to because I use Emacs, so it balances automatically. But it's
we don't think about it, right?
So, but is it still called web development with Clojure then? Because if you're going all the way, like, I don't know, the whole stack, and even maybe are you gonna write like Lisp machine in Clojure and then the whole stack?
Probably won't go that far, but no, I think it still makes sense, right? Because it's still gonna focus mostly like on server side, client side, and like I would argue mobile apps and stuff are still kind of under purview of web development because you're using the web stack to build them ultimately, right?
Yeah. Super cool. But is there any timeline or something that people can go and check, like the raw editions or whatever these people call?
We're hoping to wrap things up hopefully by end of the year. We're kind of like on chapter 5. We're looking to 8 to 9 chapters, so we're halfway through.
Okay.
Scott Brown is my co-author, and he is kind of working right now on chapter 5, I think, as we speak. So we're hoping to have something soon.
Yeah.
Like, I know Pragmatic, they do kind of those early editions where you can buy it
something
before
like that. Yeah,
completely ready. So as soon as it's up, I'll talk about that.
perfect. Okay, so any other topics you want to touch upon?
One quick one I'd like your opinion on, actually, Dmitri, is the kind of something I'm excited about anyway, which is the sort of revolution that Defn is bringing.
Yeah, it's interesting. Like, on the one hand, it's a new build tool, which fractures our existing build tools. On the other hand, I do see how it reduces the barrier to entry, right? Because now you can just get Clojure, it'll have its own way to read libraries, and if they're publishing GitHub, now you can get them without going through Maven and so on. So I do think it adds value. Like, I'm not entirely convinced it could have been done as a lane plugin, for example, but I can see the argument the Cognitect makes for why they did it the way they did it. So I guess we'll have to see. I really hope it'll at least integrate with Lane at some point. And I think people have done a bit around.
Actually, I think Lane already, there are tools to integrate Defn with Leiningen. So
right, yeah, no, that's what I mean. Like driving it from Leiningen as a plugin or something.
Yeah, that's already there though. There's a line Deps tools. Yeah. Yeah,
so I think like as long as it becomes kind of seamless, I think it's nice, and I do think it gives us more options. But I haven't really used it like much myself, so I don't really have a strong opinion on it one way or the other.
You've got to upgrade Luminous to go with the CLJ new. Come on. Then we can get the latest. We can get the latest greatest as Git shards, and we don't need to worry about this Maven stuff. You know.
But I think like in real world projects, you're still going to be relying on JVM libraries that are in Clojure, right?
But you can still do that with Defn.
I suppose,
and via
right?
shards as well, you know, so it's no problem.
So yeah, like, I mean, maybe like what Lane should do is really just get rid of its own dependency management, just farm it out to CLJ dApps, and then just be more of a build tool as opposed to dependency management tool.
But I wonder how we're going to cope up with all the force pushes people are doing, you know, with these Git shows everywhere. Like, that's going to be amazing. Oh, well, you know. But at least, you know, it's not like fucking requirement.txt or some shit like that.
No,
so it's slightly better.
I think, like, using tags is probably, like, a decent compromise. And then, like, right, like, if you're going, like, against master, that's, like, YOLO.
Yeah, exactly.
So you have to have at least some process.
I'm not sure there is a single language that is able to solve this dependency shit in a proper way. I mean, every language has the same problems, and since the Perl days, or you know, the only thing that you could do is basically, okay, you know, and do the anon CVS, check out the whole shit, and then compile it yourself, and then hope that it's going to be okay.
No, it's a hard problem, right? And
by the way, like, just to mention that if you go on, you never depend on master. You always depend on a particular SHA. So you're never really tracking. You're never tracking the commits.
Yeah, that's true. That's true.
You're only ever tracking. You're only ever depending on one version of it. I mean,
unless they
yes, people can overwrite it. I get that. Yeah. But
exactly.
That's not good practice. Let's say, you know, that's not how things should work. You know.
Yeah. But yeah, I mean, I think you're right, Dmitri, right? I mean, this is a really hard problem to solve. I mean, we haven't been able to figure this shit out in any, I don't know, any language so far. Every language has its own, you know, I don't know, workarounds for maintaining your dependencies properly.
Exactly.
Yeah, but at least I think this is the weird part, though. I mean, we are so. Maybe I'm getting older and older, and then so like, you know, everything is fucking cynical now. Like, oh, you know, we can't get this shit run properly anywhere. So what I'm gonna do is completely package my entire fucking computer. You know,
put it in a Docker container.
Exactly. Go, yeah. So put every shit into that one, and then just ship it. That's way easier than to actually solve that I can run this code anywhere I want.
It's also amusing,
that is the state we are in, which is amazing.
Like, coming from the JVM, like, when you look at Docker first time, you're like, oh, so we had this, like, for decades.
Yeah,
Right?
exactly.
Like it lets you like Docker Compose and stuff lets you add like databases and so on. But just the idea of packaging your code, right? Like on Node, like a Docker container of a Node app is basically an Uber jar.
Yeah.
Right? And I think like the people like complain about Maven, but like you look at every other dependency management system, like NPM, and you're like, yeah, they knew what they were doing. Right? Like stuff is NPM. It's like, oh, why do you need to specify a version for the library you're depending on? I'll just depend on whatever version is available. It's like,
exactly.
good luck with
That's
that.
the worst idea.
Yeah. But the nice thing, quote unquote nice thing, is that the proliferation of these ideas across languages. I mean, every time I go to Python, the first thing I have to do is install pyenv, so I can actually have 2.6.2, 2.6.3, whatever the bullshit that is. And then the JavaScript guys started the same shit with multiple environments. And then Ruby people have the same thing. It's just crazy. I mean, it's instead of solving the problem, they're like, oh, this is basically forked from Ruby multiple env, so we're just going to use Python compiler in it, and then we're done. So anyway.
I think we need to move to things like Nixos and stuff like that.
Yeah, of course. It's like that XKCD, like a 15 standard. Let's bring a one more standard here.
Well, you can't fuck with Nixos, so that's a good thing.
Yeah, that's true. That's the immutable
thing. They can have that
right?
on a T-shirt for free,
Anyway, so but of course, we have our own problems to solve with all the dependency shit. I didn't use Depse Eden, by the way, so maybe that's the magical thing that's going to solve everything.
I've got to say, I've been using it a lot in the last few months, and I really like it. So, I think I've taken the red pill, however it is, the blue pill, whatever these pills are. I've taken one of them. It's really good. I've taken the Depths pill, and it really is nice. It's very enjoyable. Yeah.
But isn't this going to be tricky to say, hey, which version of this library we're using? Yeah, that's FC7994432DBBCCA bullshit.
Well, you can. Well, like Dmitri says, you can tag it. It's no problem.
Yeah, and I think that's going to become a bit of a best practice, right? Tag your releases.
So.
But then, like like if somebody pushes like a commit to a bug fix and gets merged, they can just start using that commit right away, and then when the tag comes out, you'll swap to the tag, which is handy.
That's true. Yeah.
But I do think, like in general, right? Like the situation we have with tooling and the language enclosure is so much better than many other languages, right? And especially mainstream ones. Like for all the complaining.
Just a small point there. I mean, the reason why I like deps.eden and things like that is because you don't have to run build tools. I mean, to me, I have Clojure. What am I building code for? I mean, I know there are some interop things, but fuck that. If I don't need it, why am I building anything? I don't want to build anything. I just want to write my code, put it on GitHub, and then run it somewhere.
Yeah, and I think I
like that.
As a side effect of that too, right? Is with Clojure, like like with Scala, like every few releases they would break the bytecode compatibility, right? And you have to rebuild the whole world. Like the fact that we're able to package libraries as just source, and you just pull all the source in and compile it against your version of Clojure compiler in JVM, that's huge. Right? Because like it makes your language so stable. Like at work, we updated to JDK 10 recently from JDK 8. We haven't had to change a single line of code. Like we waited for Lane Engine to, fix up the couple of bugs they had, and I think Clojure script compiler, and then we're just like, oh, we'll just update a couple of dependencies and done. But like Java projects to this day aren't able to do that. Like IntelliJ still runs on JVM 8.
Yeah.
They're not here like Spring. Like I know a lot of people working like with stuff like Spring, right? And their companies are basically just keeping it frozen because it's too much work. And with Oracle having this aggressive update schedule every 6 months, using Clojure, right? Like you're basically insulated from that. Like we just update JDK version, and as long as Clojure compiler runs, we're cool. Like that's amazing.
Yeah. So
anyway, we've expanded the time limit now.
Yes.
This is too good.
I do talk a lot.
Yes. Amazing discussion, by the way. So I think we are almost at 1 hour, 20 minutes. Yeah, pretty much. Again, thanks a lot, Dmitri, for joining us all the way from cold Canada.
Yeah, absolutely. Thanks for having me. It's unseasonably warm now that our planet is cooking. We had a 40-degree weather a couple of days ago, which is not usual for Canada.
Oh, you mean 40 degrees Fahrenheit?
No, Celsius. I wish.
What? 40?
Yeah.
What the fuck? Okay.
It was the hottest day, I think, in September in past 75 years or something. It's
okay, because I thought Canada is always in my imagination. People are drowning in snow, and with seals everywhere.
Yeah, but global warming is a thing, VJ.
It's happening.
We know this is because of the static compilers. Yes, I think we should start spreading these words slowly. Yes.
Hashtag static compiler. Hashtag save the world.
Static language causing global warming. Yeah.
Let's go to the narrative.
Actually, good point. We should say, you forget Bitcoin, look at static compilers.
It's like recompile, anything that doesn't have a REPL, right? If you don't have a REPL, you're unethical.
Yeah, and
yes. You're killing
the worst
planet.
part is writing your blockchain shit in Haskell. That is the ultimate crime. There's the next level.
Yeah.
It's like killing dolphins or some shit.
Literally.
Okay. Anyway, I was actually thinking, that in this podcast we've been having a lot of Clojure people, of course, because we just want to live in our own bubble and then tell each other that everything is awesome. And so I was thinking at some point we should
spoil it.
At some point, I was thinking, we should invite other people to basically get insulted by them or insult them. So maybe we should try that experiment at some point.
Oh my god!
Get like Martin Odersky and Philip Wadler and and tell them that you're the reason. The world is burning now. Okay, they're not going to show up in this podcast anyway.
But it's really interesting, right? To debate with people who are really. As long as they're willing to have an honest debate, it's interesting, right? Because you get the different perspective and different opinion. And I just want to reiterate my position too, that I have absolutely no problem with static typing or people using it. I think it is valuable and interesting approach. My
come on, don't be diplomatic. I mean,
the only approach.
Come on, don't do it. Don't middle ground us, Come on.
No,
exactly.
But at the same time, my experience, I personally, in 20 years of doing development, I have not found the value of that approach, right? So when I talk with people who have, I'm curious to see, get in their head and see, how does their mind work? What problems are they having that I haven't encountered and why? And, why do they find this value? It is interesting to me because I don't see it. I don't find it. Yeah. Obviously, I write real-world software and I have been for a long time. So, show me what it is that you see that I don't see.
Yeah, but that's like talking to cult people, Fucking pointless.
So, on that bombshell...
Good luck with that.
We have come to the end of the episode already. Again, thanks a lot, Dmitri, for joining us. It's been a very fun conversation. Thanks a lot.
But for this particular cult podcast, yes.
Yes. So that's the end of episode number 39. Yeah. Of course, the credits, that's with Dmitri, are also known as Yogthos, everywhere on the internet. And he's the dynamic typing fanatic who doesn't like static typing, as you heard already. And of course, we are on the web. And if you think we're doing a decent job, we have this Patreon thing going on. And we did a slight modification to our website, which basically saying we're now pushing everything into SoundCloud as our website. So all the links, etc., should be there in the show notes on SoundCloud because, we don't have time to maintain all the multiple channel media empire that we have. So we're trying to focus on one thing. So if you like the podcast, feel free to hit us up on Slack, Clojure in Slack. We are on Defn podcast, and the Twitters and shit and everything. We usually respond to people, and Ray gets into arguments with them.
Yeah,
and it's much more fun over there.
We've got to get the begging ball out as well a little bit. You know.
Oh yeah. So we have Patreon.
Maybe I should do that rather than let you do that.
Yes,
you know?
please.
Yes.
Go ahead. Yes, ask for money.
Yeah, because we are desperately poor Clojure developers. We need the money. No, it's really nice. I mean, we've got some Patreon supports, which is really good, and we one of these days we're actually going to say what we're going to do with the money. We do a little bit of money with, like, we have to spend money on SoundCloud and stuff like that, but and I think we've actually funded Wouter to come to a conference so that he's now going to be using Clojure. So we've kind of brought one on. The Patreon has helped to bring a new Clojure developer into the world, which is good. So if you want more of that, give us $1 or $2. It'd be really good.
Yes. So the link will be everywhere online. So that's it from us. And so please give us money and have a nice day. And that's it. Bye.
Bye.